Hey everyone, in this video we're going to learn about AWS's Elastic Kubernetes Service, or EKS for short. We're going to start off by going over the basics, so we're going to learn about what is EKS, why would we want to use it, and we're also going to discuss some of the benefits a managed Kubernetes service provides us. Following that, we'll take a look at the architecture, and then I'll walk you through all of the necessary steps that you have to go through to provision a Kubernetes cluster on EKS. After we're done with that, I'll then show you guys how we can simplify the entire process by making use of a great command line utility called EKSCTL. So I'll show you guys how we can actually provision a cluster and all of the necessary resources to get that cluster functioning properly on EKS using nothing more than a single command. And that's all through the power of that command line utility EKSCTL. So what is EKS? EKS is AWS's managed Kubernetes service. And if you don't know what a managed Kubernetes service is, it basically means that AWS is going to be responsible for managing the control plane of your Kubernetes cluster. So it's going to provision, maintain all of your master nodes for you. It's going to set that up. It's going to install all of the necessary control plane processes. So it's going to install the API server on those nodes. It's going to install the scheduler, the controller manager, as well as etcd. And because you're running an AWS managed service, AWS is going to make it very easy to scale up and back up your cluster. And since AWS is now responsible for your control plane, you no longer have to worry about that. You don't have to touch it. The only thing that you have to worry about is the worker nodes. So that's the only thing as a customer that you have to configure and manage yourself. So why exactly would we want to use EKS or really any managed Kubernetes service provided by any of the major cloud providers? Well, for anyone that's ever worked with Kubernetes, you already know just how difficult it is to run, operate, and scale a Kubernetes cluster. And so by offloading this responsibility onto AWS, you no longer have to worry about the complexity overhead of managing a Kubernetes cluster yourself. In addition, with your Kubernetes cluster, you're going to have to worry about security and hardening your cluster, and you can best be assured that AWS is going to be running all best practices when it comes to security, so you no longer have to worry about that. And lastly, you're going to have to make use of other AWS services, and you're going to find that when you're working with EKS, it's very easy to integrate with all of the other major AWS services. So things like S3, IAM, Secrets Manager, and Load Balancer. So we've established that EKS is only going to be responsible for managing the control plane nodes. But what about the worker nodes? What do we do about those? Well, since EKS doesn't actually do anything with the worker nodes, it's our responsibility to set up the worker nodes ourselves. And there's a couple of different options when it comes to provisioning and managing our worker nodes. The first way we can do this is using self-managed nodes. The other option is using managed node groups. And lastly, we have Fargate. And I'm going to cover these three methods in the next couple of slides just to go over what are the differences between these three and when would you want to choose one over the other. So the main idea behind self-managed nodes is that users must provision all of the EC2 instances manually that they want to use as worker nodes. And they're going to have to set up and configure them so that they can operate as worker nodes in a Kubernetes cluster. And that's going to be doing things like installing all of the necessary processes like kubelet, kubeproxy, as well as container runtime. So all of these are your responsibility. You have to manually set them up yourselves. In addition to that, you have to update your servers regularly as well as patch any security vulnerabilities. And that's exclusively up to you. AWS is not going to help you with that. And finally, after you configure your worker nodes, you're going to have to then register them with the control plane. Managed node groups are going to be a little bit different than self-managed nodes. And the main difference is AWS is going to help automate the provisioning and lifecycle management of the EC2 nodes. So you're not doing all of the work yourself. And it's able to do that by using a special EKS optimized image that your nodes will run that'll make it integrate better with Kubernetes and EKS. And what AWS is going to do is it's going to provide a streamlined way to manage the lifecycle of all your nodes using a single AWS API call. So if you want to create new EC2 instances, it's just one single command or just a click of a button. If you want to update a server, it's very easy to do. And you can also terminate instances just by making a single API call. And lastly, every node is going to be part of an auto-scaling group that's managed for you by EKS. So managed node groups are still managed by you, but AWS and EKS are going to provide tools to make it a little bit easier to manage the lifecycle. So creating, updating, and terminating these servers will be a little bit easier than you doing this all by yourself using self-managed nodes. The final method for deploying worker nodes in an EKS environment is by using Fargate. And Fargate follows a serverless architecture. And with a serverless architecture, you don't actually have to provision or configure any of the worker nodes. You don't have to configure any EC2 instances whatsoever. Instead, what happens is when you deploy resources onto your Kubernetes cluster, Fargate will actually take a look at what needs to be created and will actually create all of the worker nodes on demand. And that way you don't have to touch any EC2 servers. It's all managed by Fargate. You never have to worry about creating or deleting or provisioning any EC2 instances. And the great part about Fargate is that it's actually very intelligent as to what EC2 instances it should create. So it'll take a look at all of your container requirements and figure out the most optimal EC2 instance size that it should use so that you aren't either using an EC2 instance that's underpowered for your workload, or as well as not using an EC2 instance that's far too powerful for your workload, thus resulting in you spending unnecessary extra money. And the great part is you only have to pay for what you use. So as your application grows, you'll see that Fargate will scale up. And if your workload starts to go down, it'll actually start scaling down resources so that you don't have unnecessary EC2 instances just sitting around doing nothing. To create an EKS cluster, there's going to be a couple of things that you're going to have to configure. The first thing is you're going to have to give the cluster a name, as well as what Kubernetes version you want to run. You're going to have to give it a IAM role for the cluster so that it has the necessary privileges to perform all of the various operations that it needs. So things like being able to provision nodes, accessing storage, secrets. The next thing that you're going to have to do is select a VPC and subnets that you want to run your EKS cluster on. And finally, you're going to have to define a security group for your cluster so that you can kind of lock down what traffic is going to and from that cluster. After you've created your EKS cluster, you're going to then have to create your worker nodes. And so there's going to be a couple of different steps for this. The first thing that you're going to have to do is create a node group. And a node group is nothing more than just a group of nodes that you're going to use as worker nodes within your Kubernetes environment. You're going to have to specify what instance type that you want to use for your EC2 instances. You're going to have to define the min and max number of nodes that you want in your node group. And you're going to have to specify which EKS cluster you want to connect to. So you're going to connect to the EKS cluster that we created in the previous step. After we've configured the control plane nodes and the worker nodes, the next thing that we want to be able to do is connect to our cluster from our local machine so that we can run kubectl commands on our newly created cluster. And the way we can do that is by going to the console, getting the connection information for our newly created Kubernetes cluster, and running a kubectl config set cluster and passing in the information that we have within the console. And at that point, you should be able to then deploy resources onto your Kubernetes cluster. In the past couple of slides, we've gone over all of the necessary steps that we have to go through to get a fully functioning Kubernetes cluster running on EKS. And there's actually a couple of different ways to go about performing those steps. The first way is the most obvious way. That's just by using the AWS console. So you can log into the console, go to the EKS tab, and then go through the configuration wizard to get that set up. And that's perfectly fine. However, it's a little bit of a long and complex process because you're going to have to create the EKS cluster, you're going to have to create the worker nodes, and then you're going to have to set up kubectl on your local machine to be able to connect to the Kubernetes cluster. And that's not even including all of the extra steps like provisioning a VPC and all of the subnets and handling all the routing. And so doing this through the console is a very long and tedious process, and you want to look for ways so that you can actually automate these things, or at least streamline the process so it's a little bit more quicker and more efficient. And a tool was actually created to help with this, and it's called EKS-CTL. And this is a tool that was actually created by Weaveworks that will simplify all of this processes, and it'll actually set up your cluster with just a single command. So all you have to do is just run EKS-CTL, create cluster. It's going to provision your VPCs, your subnets. It's going to provision the control plane, the worker nodes. It's going to provision the node groups, and it's going to do all of that for you with just one single command. And deleting a cluster is just as easy. You could just run EKS-CTL, delete cluster. Now, the final method to creating an EKS cluster is by using infrastructure as code tools. So things like Terraform and Pulumi, and that way you can define your infrastructure configuration in code, and then you can just deploy that by using Terraform or Pulumi. So those are the three main methods. In this video, we're going to focus on using EKS CTL. I think that's one of the simplest solutions to getting a EKS cluster running in AWS. And so let's go ahead and get started installing and setting up EKS CTL on our machine so that we can provision our first EKS cluster on AWS. To install the EKS CTL tool, you can navigate to the Amazon EKS documentation, and I'll provide a link to this in the description as well. But if you go under Getting Started with Amazon EKS, select Installing EKS CTL, and it's going to provide you step-by-step instructions for installing it on your respective operating system. You can see they've got instructions for macOS, Linux, and Windows as well, and you just have to follow the instructions and you should have it installed with no issues. Once it's installed, you can verify that the installation was successful by running an EKS CTL version. And that's going to tell you what version you have, and if it prints out a number like this, that means it was successfully installed. So now that we have the EKS CTL tool installed, the next thing that we have to do is set up authentication for the tool so that it's able to talk to the AWS API and configure resources within our account. And so the first thing that we have to do is we have to get some credentials for our user. So if we go to the management console and go to IAM, then go under the specific user you want to use for your EKS CTL command line tool. Here I have a user called admin. We want to then go to security credentials, and you want to select create access key. And so here it's going to provide the access key. I'm not going to select the show button because you guys don't need to see that, but just select show, or you can even download the CSV file to get the access key as well as the secret key. Then once you have these credentials, there's a couple of different ways to actually set this up, and it's going to follow the same exact steps as it would if you were setting up the AWS CLI tool. I'm not sure how familiar you guys are with that, but if you ever used AWS CLI tool, it's the same exact way. So if we go to the documentation for the AWS CLI, and once again, I will post a link of this in the description, you want to go to configuring the AWS CLI and select configuration basics. So there's a couple of different ways of doing this. If you have the AWS CLI tool, you can just run AWS configure, and it's going to give you a prompt where it asks for the access key ID that we just got, and then the secret key, and then you can provide your default region, and then the default output format. So that's one way of doing it, but if you don't want to install the AWS CLI, you can go to the configuration and credential file settings. And down here, it shows you how to set this up. So in your home directory, this little tilde means your home directory. You want to go into the .aws folder, and you want to create a file called credentials. And you want to write it out exactly like this, but just replace the access key with your access key and the secret key with your secret key. And then in that same folder, you want to set up a config file that's going to provide the default region and output format. So you can see in my home directory, so it's under, since I'm on Windows, it's going to be the C drive, users, and then my username. There's an AWS folder that I created. And then I have this credential folder, and I'm going to open this up real quick. And we can see that that's all I did. I just set up default, and then I provided the access key and the secret key. And that's all you have to do to set up authentication. And at that point, the EKS CTL command line tool should be able to talk to the AWS CLI or the AWS API. So now that we've got authentication set up, it's time to go ahead and create our cluster using the EKS CTL command line tool. And what I recommend that you do is before you actually create the cluster, I recommend you do an EKS CTL --help. So this is going to show you all of the different commands that we have at our disposal, and it'll help you familiarize yourself with the tool. And so here under commands, you can see that there's a couple of different commands, but the two main ones that I want to focus on for this video are EKS CTL create, which is going to be responsible for creating a cluster. And then you want EKS CTL delete, which is going to delete the cluster. So I'm going to do an EKS CTL create, and then we'll do --help to see what other options we have. And here we can create a cluster, an add-on, a node group. In this case, since we're creating a cluster, we want to select a cluster. So I'm going to do EKS CTL create cluster --help. And here you're going to see all of the different flags. And there's going to be a couple of flags that we're going to have to provide. And the first one is going to be the -n or the --name flag, which is going to give our cluster a specific name. If you want to specify a region, you can do the -r flag. And also, if you want to specify availability zones, you can also do the -- zones flag. You will need to pass in at least 2 zones because we have to set it up for high availability. The next thing to point out is that by default, it's going to use a managed node group. However, if you pass in the -- Fargate flag, then it's going to use Fargate for your worker nodes. And if you take a look at the node type flag, this is going to be the specific EC2 instance type that you want to use. Do you want to use a T3 micro, whichever size EC2 instance that you want to use. And then the nodes flag is going to tell how many nodes that you want running in your specific cluster. The default is going to be set to 2. So those are all of the main flags that we need to use just to kind of get our first cluster up and running. You can obviously customize it however you would like. So I'm going to go ahead and I'm going to type in EKS CTL create cluster. I'm going to pass in the -n flag to give it a name, and I'm just going to call this cluster 1. The next thing that I want to do is, since it's going to create a node group, I want to go ahead and give that node group a specific name. It will give it a default name, but I'm going to give it my own custom name. So I'll say node group -name. This is going to be set to, I'll just say node group 1. Region, I'm going to use US East 1. Feel free to use whichever region is closest to you. And then for the node type, I'm just going to use the T2 micro. And then lastly, I'm going to specify the number of nodes I want, which is going to be 2. And then I can go ahead and enter. And then you're going to see that it's going to get started on provisioning our cluster. And you'll see that provisioning a cluster on EKS actually takes quite a bit of time. So just go ahead and just wait a couple of minutes, and then it should wrap up. And then we can take a look at what was the end result on the AWS console to see what changes were actually made and what was actually created through this CLI tool. So it looks like it's finished creating our cluster, and there's no errors of any kind, so it looks like it was successful. So let's go to our AWS console and let's take a look at what it created. And I first want to take a look at the VPC section because it is going to create a VPC for our cluster. And if I go down to VPCs, we can see that there was a VPC, and it's going to be the one that's prefixed with EKS CTL, so it created a VPC. And if I go down to subnets, it's actually created 4 different subnets. So I've got 2 public subnets, and they're all going to be the ones that are prefixed with EKS CTL. So we've got 2 public, 2 private. And if we take a look at the public subnets and the route table, they've also set up the routing in these subnets. So we can access the internet because the internet gateway was successfully set up as well. So these are all things that were done and handled by the EKS CTL command line tool. And that's pretty much what I want to cover from the networking section. So let's then go to the EKS service. And in the EKS service, you can see the one cluster that was created. That's cluster 1. We can see it is in an active state, and we can even see what version of Kubernetes it's currently using. And then it's got some other information in the details section, like where is the API server endpoint so that you can connect to it and run kubectl commands. If we go down to compute, let's take a look at the worker nodes. We can see that we have one node group that was configured with the name of node group 1. And I specified that I wanted 2 nodes in that node group, so we can see the desired size is 2. And if we take a look at the nodes, you can see we have 2 different nodes with the T2 micro, which is what I specified as well. And if you want to go to the EC2 dashboard, you can actually go take a look at the instances themselves, and we can see the 2 instances that were created by EKS CTL. So we've got our control plane and our worker nodes set up. The last thing that we want to do is we need to make sure that we can connect to the new cluster that was created. So we have to update our kubectl config. And the great part about EKS CTL is it actually does it automatically for you. And so if you take a look at the logs, when you ran the EKS CTL create cluster command, you could see this line right here, which is saying that it's already updated our kubectl configs. So if I clear this and I do a kubectl config view, and I scroll to the top, we can see that the new cluster was actually added to our kubectl config right here. So we can see cluster 1 US East 1 EKSCTL.io. So that cluster was added, and all of the configuration is down here as well under the context. And that's going to be right here as well. So everything should be set up and we should automatically be able to connect to it. So if I do a kubectl get nodes, we should see that it prints out the 2 nodes that we have within our node group. So we have successfully set up an EKS cluster with the control plane and the worker nodes, and we've updated our kubectl configs so that we can connect to the Kubernetes cluster. And that was all done using that one single command from the EKSCTL command line tool. So now we can go ahead and clean up our resources by deleting the cluster, and deleting the cluster is just as easy as creating it. We can just do EKSCTL delete cluster, and then we just provide the flag of the name, so -n, and then the name of my cluster, which is cluster 1, and EKSCTL is then going to go in and delete our cluster, as well as all of the other resources like the VPC, the subnets, the node groups, and anything else that it created for us. Okay, so it's done deleting our cluster, and if we go back to the AWS console, we can just hit refresh here just to make sure that it did successfully delete it, and we can see that the cluster is now gone.
KodeKloud Playgrounds give you instant access to cloud and DevOps-based environments where you could try out various features and technologies. That way you can get a sandbox with your desired technology pre-configured and ready to go with just a click of a button. And you won't have to worry about any surprise cloud bills, and you won't have to remember to tear down any of your environments. There's an ever-expanding list of different playgrounds available at your fingertips, and if you'd like, you can even submit ideas for new ones as well. So if you want to try out one of the cloud providers or learn something new like Istio, we'll have you covered. So head on over to the Playgrounds page at KodeKloud and get started learning today.
Okay guys, so that is everything I wanted to cover in this video. Hopefully you guys now have a solid understanding of what is EKS and how to actually deploy a cluster onto EKS using the EKSCTL command line utility. So hopefully you guys enjoyed this video, and I will see you guys in the next one. Thank you.